Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, at DG Khan campus. Dear students, our today's lecture topic is UDP or User Datagram Protocol. In the previous lecture, we have studied about TCP, which was Transmission Control Protocol. Transmission Control Protocol was reliable protocol, and there was a concept of flow control as well as error control. Transmission Control Protocol also supports three-way handshake, which is compulsory for reliable communication. But the User Datagram Protocol is unreliable protocol, so we will discuss in detail about UDP in today's lecture. What are objectives? Upon completion, you will be able to explain process to process communication, know the format of a UDP user datagram, be able to calculate a UDP checksum, understand the operation of UDP, know when it is appropriate to use UDP, and understand the modules in a UDP package. Position of UDP in the TCP IP protocol stack. Dear students, in this slide we will see different protocols which are deployed on different layers of OSI reference model. So you can see physical and data link layer, which deploys underlying LAN or WAN technology. On network layer, there are different protocols: IGMP, which is Internet Group Message Protocol; ICMP, which is Internet Control Message Protocol; IP, which is Internet Protocol; ARP, which is Address Resolution Protocol; or ARP, which is the Reverse Address Resolution Protocol. And on transport layer, SCTP, which is Stream Control Transmission Protocol; TCP, which is Transmission Control Protocol; and UDP, which is User Datagram Protocol. So the basic purpose of this slide is to know where UDP is deployed. So UDP is deployed on transport layer of OSI reference model. And the last layer is application layer, on which SMTP, Simple Mail Transfer Protocol; FTP, File Transfer Protocol; TFTP, Tribal File Transfer Protocol; DNS, Domain Name System; SNMP, Simple Network Management Protocol; and BOOTP. So these are different protocols which are deployed on different layers of OSI reference model, and the UDP is deployed on transport layer. Process to process communication. Before we examine UDP, we must first understand host to host communication and process to process communication and the difference between them. The topics discussed in this section include port number and socket number. So there are four major concepts. First is host to host communication, second is process to process communication, third is port number, and the last one is socket address. So we will discuss throughout the lecture about these four concepts. UDP versus IP. Dear students, in this diagram you can see the communication between two hosts. So if there is sender and receiver, source or destination, these two systems are called host, and between these two systems we use IP as well as we use UDP. But if you will see, the domain of IP protocol is written between two hosts. It means when the communication in between two hosts, IP protocol is commonly used, and below this you can see domain of UDP protocol, which is between two processes. What is process? Whenever you open any application, any program, that is called a process. First of all, that is an application, and when you run that application will become a process. So between two processes, the communication is dependent on UDP. So process to process communication, we use UDP protocol, and between host we use IP protocol. In the previous slide, we have just said that we will study in detail about process to process communication and host to host communication, port number, and about socket. So process to process communication and host to host communication is discussed in this slide. Port numbers. Dear students, first of all, we must understand what is port number. So every protocol contains a specific decimal number which is called port number. I am going to repeat again. Every protocol contains a specific number which is called port number. You can see this diagram. There is communication between client and server. Client is being used 52,000 port number and server is being used 13 port number, and in packet you can see data as well as port numbers. So port number is a specific predefined decimal number which is allocated to a specific protocol. IP addresses versus port number. What is IP address? Every device on the internet is being assigned a specific number which is called IP address. So over here you can see a device which is using IP address 193.14.26.7. This is IP address which is assigned to this system. And if this system is going to use a specific protocol, then the specific port will be used, and TCP is being used over a specific port number, IP is being used on specific port number, UDP is being used on specific port number, HTTP is being used on specific port number. Over here port number 13 is defined. It means this system is going to use UDP, and UDP is deployed on port number 13, or the specific decimal number which is assigned to user datagram protocol is 13. So IP address is 193.14.26.7 and the port number is 13 for user datagram protocol. ICANN, Internet Corporation for Assigned Name and Numbers. This organization assign the numbers for different protocols. Question is this: how many protocols are there? So there are total 65,535 protocols. So these decimal numbers are assigned to a specific protocol. Let's suppose between 0 and 65,535 is 100. So 100 decimal number will be assigned to a specific protocol. Hypertext transfer protocol is being used at port number 80. From this diagram you can understand the left portion which is well-known protocols. So 0 to 1023, these are well-known protocols or well-known ports. Next 1024 to 49,151, this range is for registered. So any protocol which is being developed by any specific organization, that organization will register that port number to ICANN. And the last is dynamic or private. These numbers are private and used by any organization, any person for any research purpose. The well-known port numbers are less than 1024, as I have just said in the previous slide that the well-known protocols are between 0 to 1023. So these are total 1024. Example 1. Dear students, this is an example of configuration. Some commands are shown over here. So SNMP, Simple Network Management Protocol, uses two port number 161 and 162, each for different purposes. So just we have to use these commands on command prompt while configuring different protocols, especially TCP and UDP. So SNMP 161/TCP and Simple Net Management Protocol. So when we enter these commands, we can see the configuration about TCP as well as UDP. Socket address. In this slide, dear students, you can see an IP address and port number. First of all, IP address is 200.23.56.8. This IP address will be assigned to any computer or laptop which is on the internet. So for WAN transmission or to use internet services, IP address is assigned, and after that a specific port number for specific protocol is being used. So protocol is UDP and the port number is 69. It means a system which contains the IP address 200.23.56.8 is being used user datagram protocol for specific data transmission, and the port is 69. Combination of IP address and port number is called socket. I'm going to repeat again. Combination of IP address and port number is called socket address, and this is separated by colon. So what will be the socket address? Socket address will be 200.23.56.8 colon 69. So socket address is combination of IP address as well as port number. User datagram format. So dear students, over here you can see header portion and data portion. Data portion is actual portion which is transmitted from sender to receiver. So this is actual data. These are segments which are being transmitted from source to destination. So data may be in the form of text, data may be in the form of audio file, data may be in the form of video file, and so on. Second main portion is header, which is divided into further four portions: source port number, destination port number, total length, and checksum. First of all, we will discuss about source port number. Let's suppose source, which is a specific device, is being used port number 69, which is of user datagram port number. It means that the port number will be 69 from source, and if the destination, that is again specific computer which is receiving the data from sender on UDP port number 69, so this will be destination port number. So port numbers are for specific protocols. This is very important to understand the difference between IP address and the port number. IP address is a specific address which is assigned to a system, and the port number is for specific protocol. Next is total length, which is 16-bit, and after that is checksum. So what is checksum? Basically, checksum is used for error detection and prevention. So checksum is a mechanism to detect error. So this is basically header division in four different portions. Checksum. UDP checksum calculation is different from the one for IP and ICMP. IP is Internet Protocol and ICMP is Internet Control Message Protocol. Here the checksum includes three sections: a pseudo header, the UDP header, and the data coming from the application layer. The topic discussed in this section include checksum calculation at sender side, checksum calculation at receiver side, and optional use of the checksum. So checksum is a basic mechanism to detect and to correct different network errors, and three sections which are pseudo header, UDP header, and the data coming from application layer. These three portions are used to calculate the checksum. Basically, when the sender will send any type of data and the receiver will receive that data in its correct form, there will be no error. But when there is a problem which is sent by data and which is received by receiver, if the bits have been changed, then there is an error, and this error may be bit error or byte error or burst error. If single bit is changed, this is one bit error, and if more than one bits have been changed, so this may be byte error, and if this is in bulk, so this will be burst error. So errors must be directed so that the receiver must receive correct data. So checksum is a mechanism for this issue, and in next slides we will discuss in detail about the method how which the checksum is calculated. Pseudo header for checksum calculation. So our first point was pseudo header. So we will see which specific fields are in pseudo header. So you can see in pseudo header there is 32-bit source IP address, there is 32-bit destination IP address, next field is all zeros, next is 8-bit protocol, next is 16-bit UDP total length. So these portions includes in pseudo header. Next is header, which we have discussed in our previous slide: source port address, destination port address, UDP total length, and checksum. So our main discussion is about pseudo header, which is again dependent upon source IP address, destination IP address, next three fields all zeros, 8-bit protocol, and 16-bit UDP total length. And the last is data. Padding must be added to make the data in a multiple of 16 bits. What is the concept of padding? If the minimum length of data is not fulfilled, then the extra bits are attached, which is called padding. Let's suppose if the length of packet is 48 bits, but the length is not being completed 48 bits, this is just 46 bits, so 2 bits will be added. So these 2 bits are called bit stuffing, and this concept is called padding. So dear students, in the previous slide we have seen the concept of pseudo header and header. In this slide we will put different values to calculate checksum. So over here 153.18.8.105 is source IP address, 171.2.14.10 is destination IP address, next all zeros, next 8-bit protocol which is 17, next 16-bit UDP total length which is 15, next source port address which is 1087, destination port address which is 13, UDP port length which is 15, and next is all zeros. And T T-E-S-T-I-N-G, all zeros. These are examples of data, T-E-S-T-I-N-G, and after that all zeros, this is for padding. On the right side you can see the conversion of decimal into binary. So 153.18 is converted into binary form, 8.105 is converted into binary form, and so on. So all the fields of this header will be converted into binary form, and we will calculate the sum of these values. When the sum is calculated, you can see the sum of all these values is 100101110 and 111011011. So what will be the checksum? The reverse of the sum will be the checksum. So the checksum is 011010001 and 0001010. UDP operation. UDP uses concepts common to the transport layer, as we have discussed that UDP is deployed on transport layer. These concepts will be discussed here briefly and then expanded in the next chapter on the TCP protocol, although we have discussed TCP protocol before UDP. So the topics which are important about UDP operations or the characteristics of UDP is connectionless service. So UDP offers connectionless service, flow and error control, encapsulation and decapsulation, queuing, multiplexing and demultiplexing. So these are different features which are provided by UDP, or these are different operations which are provided by UDP. So in today's lecture we have completed the concept of UDP, and we have seen about process to process communication, about UDP user datagram, about UDP checksum, about the operation of UDP and how UDP works, which port number is assigned to UDP, and on which layer of OSI reference model UDP is deployed. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.